Today we're going to be talking about how to find the angle between two vectors, and in this particular problem we've been given two vectors, one represented by 3, -1, 5, and the other represented by -2, 4, 3. Now remember that this notation for vectors tells us that we have a vector that starts at the origin, where the initial point is at the origin, with a terminal point at the coordinate point 3, -1, 5. And in the case of vector B here, we have a vector with initial point at the origin and terminal point at -2, 4, 3. Now the formula we're going to be using to find the angle between the vectors is a corollary formula that's very common when we're working with vectors. It tells us that the angle between the vectors can be found using the formula cosine of theta. We're going to be solving for theta as the angle between the vectors, is equal to the dot product of A and B. This is not just A times B or AB. This is the dot product of A and B divided by essentially the length of A times the length of B. This notation here that looks like absolute value of A, it's literally the length of A, and we can find the length of A and B using our distance formula for three variables. Remember that each of these vectors here starts at the origin and terminates at this coordinate point here, represented by 3, -1, 5. So we can find the length of the vector using the distance formula for the distance between those 2 points. So let's go ahead first and find our dot product, this A times B value in the numerator of our formula. So finding the dot product, remember, is just as simple as multiplying each of the components of A and B and adding those products together. So we're going to say the dot product of A and B is going to be equal to, here we multiply the x values together, so we'll get 3 times -2. Then we add to that whatever we get when we multiply the y components together, so -1 and +4. And then add to that what we get when we multiply the z components together, 5 and 3. If we simplify here, we see that we get -6 minus 4 plus 15 gives us a +5. So our dot product is going to be 5, and that's what we're going to substitute for this dot product notation here in our numerator. Now we need to find the length of A and the length of B, both, and we're going to use the distance formula to do that. So remember, essentially we have this coordinate point 3, -1, 5, and the coordinate point 0, 0, 0. If we find the distance between those two, we find the length of the vector. So we'll say that distance of the vector A is going to be equal to the square root of quantity 3 minus 0 squared plus quantity -1 minus 0 squared plus quantity 5 minus 0 squared. Now if we simplify this, what we see is that we get the square root of 3 squared, which is 9, -1 squared, which is a +1, and 5 squared, which is 25. So essentially we've got here the square root of 35 as the length of our vector A. If we do the same thing for B, we'll say the length of our vector B is going to be equal to the square root of quantity -2 minus 0 squared plus 4 minus 0 squared plus 3 minus 0 squared. And when we simplify, we'll get the square root. -2 squared is a +4, 4 squared is 16, and 3 squared is 9. So we get 4 plus 16 is 20, plus 9 is 29. So we get here the square root of 29 as the length of our vector B. Now if we want to find the angle between the vectors, we just set these values up in our corollary formula. So we say cosine of theta is equal to our dot product, A times B here, which is going to be 5, divided by the length of A, which we already know is square root of 35, times the length of B, which we already know is square root of 29. Now we just need to solve this equation for theta. The first thing we want to do is say that cosine of theta is going to be equal to 5 divided by, we can combine square root of 35 and square root of 29. They're both essentially raised to the same exponent. We've got 35 raised to the 1/2 times 29 raised to the 1/2. When they're raised to the same exponent, we can multiply the bases. 35 times 29 is 1015, so we'll get square root of 1015 here in our denominator. To solve for cosine, we'll just take the inverse cosine of both sides, or arc cosine, and we'll get theta is equal to arc cos of 5 over square root of 1015. Now we can leave it like this, or we can approximate it to the nearest degree. If we punch this into our calculator here, we'll get theta is equal to approximately 81 degrees, 81 degrees being the angle again between our vectors A and B.